Hey everyone, I'm Aditya, and today we are going to discuss about transformers, and also we are going to cover some concepts of vision transformers, how transformers will be used in vision. So let's get started. So transformers, we you probably have heard this name before if you are generally into machine learning and deep learning. So transformers, they were currently they were first used in NLP tasks. So NLP tasks such as language translation, alright, speech recognition. So such tasks of NLP, they before they used to have architectures such as RNNs, LSTMs. Alright, so using these algorithms, they used to implement in NLP to accomplish these tasks. Alright, so later transformers were introduced. Transformers are basically known for their long range dependencies. So that's what they were famous for. So transformers were introduced in 2017 first, and it totally changed the entire era of NLP. Okay, so let's get started. So this is the architecture of transformers, and transformers basically they say that it gains its power, or the fundamental basis of transformers is all formed due to attention module. Okay, so the paper itself, its name is also attention is all you need. I hope you have heard it before if you are into NLP. Alright, so this is the architecture, and let's discuss briefly about this architecture. So as you can see, there are input embeddings, there is a positional encoding. This is the attention part. This is where attention takes place, and this is called encoder attention, and this is called decoder attention. Alright, so let's break it down to understand it more clearly. Alright, so what's happening inside is that first an input is given. Let's say let's understand with an example. Suppose I want to convert a language from English to French. Okay, this is the task for our algorithm. Alright, so first what I'm going to do, as an input I'm going to feed it an English sentence. Let's say my name is Aditya. In French it is je m'appelle. I'm not a French student, but this is what I remember as far as I think. Je m'appelle Aditya in French. Okay, so this is our input and this is our output. Alright, so I'm going to feed this input here, and what is going to do, it's a sequential task. The input should be given in sequence. Alright, for a transformer. So what is going to do, as an input embedding, I'm going to embed each word of this sentence with some number. Let's say 0, 1, 2, 3. Alright, so I'm going to give each word a number. Alright, after that I'm going to give the position to each number. Alright, the numbers need not be in a sequence like this. For the input embedding, the input embedding generally will be in real numbers. all right. And after that I'm going to give position encoding to uh, each word, all right. So just to say like this is going to go first, this is going to go second, this is going to go third, and this is going to go fourth as as the input, all right. So after that it is going to go to the multi-head attention layer. So the multi-head attention layer is what is the game changing in transformers, all right. So what happens inside a multi-head attention? So to understand that, let's basically understand what is attention, all right. So as you can see here, there are two images. Let's first put this multi-head attention image aside, and let's concentrate on self-attention image on the left side, all right. So as you can see, there are three vectors which are passing through this layers, all right. I'm just visualizing this multi-head attention, just this small rectangle box which is here. I'm just explaining that part here, all right. So let's get into it. So what is happening is that same input which we have given before, it is going to split into three vectors, all right. You're not really splitting it, but you are passing some weights to that. You are going to multiply some weights to the input, which is going to make it split to three vectors, which are called as query, key, and value vectors. Okay, so what are these query, key, and value vectors is that, so you can think it as a retrieval system in YouTube. So what is happening is, for YouTube, in order to search some search some for some video, what are you going to do? You're going to type some input, all right. You're going to maybe watch some video song. You give YouTube an input, that is your query, and what is going to happen is that input is going to go to YouTube, and YouTube is going to search for some samples such as video description and video titles, such as that. It is going to match, the YouTube is going to match your input with video descriptions of various videos and title of various videos, and that is your key, all right. So let's say title, that is your key, and finally it is going to present you with some results, all right. That is your value, all right. So you can think of this like that, this query, key, and value vectors, and then they are going to go through some matrix multiplications and scaling just for optimization sake, and the values are going to be softmaxed. So what is the importance of this step is that the algorithm is, this was our input, right? The algorithm is going to learn the association between each word. Okay, how this word is associated to this word is associated to this word, how this word is again associated to this to this, like that. Okay, so the association between words are going to be learnt in the attention step, all right. So it's called a self attention step. So that is all about self attention, all right. I'm not going too deep into the architecture right now because of time constraints, all right. Next we are going to talk about multi-head attention. So it is the same thing, except that the attention layers are split into various sub layers, and each layer is going to learn something about the other other words in the same input, all right. So suppose this word learned how it is associated to this word, this to this, right? So at this similarly, it is these layers, other layers are going to learn something else which is the adjective, which is the noun or pronoun in the words. That's what maybe other layers are learning. So again, all the layers will be concatenated, and all the layers will be will form a linear network. So that network will be feed forwarded with some skip connections and will be sent as an input to the decoder attention as a key and value vectors. Okay, this is key, and this is value, and this will be our query vector. So this will be going as an input to this attention layer. At the output will be given this French sentence which I have mentioned before, Shemapal Aditya. This will be going as an output vector as an input to the decoder network. So at the decoder, this will be going in the same steps which I have explained you. The positional encoding and output embeddings will be done, and with multi-hide attention as well. And later, only the query of this layer will be passed to multi-head attention. Okay, while the value and key vectors will be taken from this network. All right, and the same this is the same steps as here. And what is the purpose of taking value and key from here while only query from the output vector is that at this step the decoder is going to learn the association between the input and output. How my name is Aditya is associated with Jamapal Aditya. The associations between the input and output, that's what it is going to learn and present its output. So I hope this overview of transformers I hope you understood it. And so moving on, let's talk about transformers in vision. So later the researchers extended this research from NLP to vision. All right, so let's see how they succeeded in doing so. This paper is called Vision Transformers, which was released in 2020 of December, which is not so it is like quite recent, we can say. It's not even been 1 year since it released. All right, but this is not the first research paper that did research using transformers in vision. There were other papers as well. So but anyway, let's talk about vision transformers. All right, so it's the same architecture. They have taken only transformer encoder from this architecture. All right, this is a transformer encoder, and what is happening is, if there is an image like this, let's say this is a 16x16 image. All right, so what is the difference between this algorithm to the NLP transformer is that there they took the sentence, they divided the sentence into words, and they embedded the words and position encoded them. Here the image will be divided into patches. All right, if this is the image, the 16x16 image, let's say maybe this is one patch, this is another patch, this is one more patch. Let me change the color. This is one patch, maybe this one's another patch, and this one's some other patch. All right, so the image will be divided into such patches and will be fed to the same transformer encoder. That is what is explained here. So as you can see, this is our image, right? This is our image. So patch plus position encoding. The patch, what it means is that the image will be divided into patches, and later the positions will be encoded to these patches. Let's say this patch is 0, this patch is 1, this patch is 2, like that. So each image will be will be given a position, just like there we have given each word in a sentence a position and an embedding. Like that, here we are giving position and patch embedding. So it will be passed through linear projection of flattened patches, it's nothing but it is going to flatten all these patches at once, and will be added some position encoding at this step, and later will be passed through a transformer encoder. Alright, so again it's all the same process, the same query and key values, quiz query key and value vectors will be given, and in some skip connections, and it is going to learn the association of the of from one patch to another. Okay, so the what is the benefit of this is that if there's an image like this, there's a ball here and there's a person here. So using transformers in vision, the vision transformer tends to learn the association of elements in an image. Okay, so it gets to know there's a ball here, alright, and there's a person here. Alright, the association between each element in the same image, it is going to learn in vision transformer. Okay, the drawback of this algorithm is that it is very it takes a huge time to train. Alright, that's one drawback, and it needs a really large data set to train. It cannot be trained on small data sets. Anyway, it outperformed the other state of the art algorithms, and achieved a really great accuracy in classification tasks and object detection tasks as well. So alright, so there are three variants of this model in vision transformers. There's a base model, large model, and a huge model. As you can see that in the table, there are 12 layers. There's a hidden size. There are 12 heads. What do you mean by heads here? The attention, the number of attention layers we have seen in before when I was explaining transformers, general transformers. If there are 12 heads, that means there are 12 attention layers, right? So this is the length of the parameters. See, there's 86 million parameters. This is 307, this is 632. On an average GPU, it takes days or even weeks to train, or even more than that. There's no surprise in it, right? So these are the variants of the model, and let me just quickly show you the attention. So this is the input image, and this is not the output, but this is what the attention sees, what it is attending to in the image. This is the dog in the image, that is what it is learning. The attention is learning. So this is a plane, this is a snake. These images are what's taken from the paper itself. Alright, so I hope you understood what the vision transformers and transformers in general. It's just an overview, so due to time constraints, I cannot explain you in depth about these architectures, but I hope you understood the overview. Alright, so now let's quickly get into the code about the vision transformers. So this code which I have written, I'll quickly show you how it works. So the code is basically divided into three parts. First will be creating a patch embedding and patch encoding layers. Alright, and we'll be also creating an augmentation layer. Alright, so after that we'll be creating our transformer layer. Transformer layer, it consists of both encoder and decoder layers. Alright, so this will be our architecture, and later we are going to train it. Alright, so we'll be using TensorFlow for this experiment. Right, so let's jump into it. So first I have imported some libraries. I am going to use the Cifar 100 dataset for this. And these are some parameters. As you can see, the learning rate, weight decay, set some image size, patch size, and this is the number of patches, projection dimension. These are some parameters, and I'm going to perform data augmentation here. It's okay if you don't understand this code. It's totally fine if you are new to TensorFlow or even writing your first code in neural networks. It's okay, don't stress on it. And I've created a small neural network here. You will understand why I've done that later. This is the patch layer. This class is what is going to create the patches of the image, various patches of the image. And this is how the patches will be created, and this is where you are going to encode all your patches, and also embed you'll also add some position encoding to each patch. So this is your vision transformer layer. This is where you're going to create this. This is a transformer encoder, right? So this is what the architecture which is here. Alright, so as you can see, there's a multi-head attention, and you are giving their input here. This is a total summary of the architecture. Again, I'm saying it's totally fine if you are new to this. I'll be sharing the code, don't worry. But if you have no experience in neural networks at all, then I suggest don't look at this code first, because it will be intimidating. If you are a seasoned practitioner, then I do recommend you to try this code. I do recommend you to try to understand this code. Okay, and later you are going to run your experiment, optimizer and compiler. Here I'm going to set a sparse categorical accuracy with some cross entropy. This is the loss I'm using, sparse categorical cross entropy. It's no different from a general categorical cross entropy, the one which you will see in logistic regression if you know the algorithm there. And you are going to fit your model, and let's see some it's only 7 epochs I ran on, so it doesn't work at all, this model. It's hardly 7 epochs only, right? So these are the, as you can see, it only ran for hardly 7 epochs, and the loss is quite high. Alright, so but don't worry, like I said, it's just a small experiment. This is not an original research experiment or something. It's just something that to show people how this algorithm works. Alright, so I hope you enjoyed this session, and today we have covered about an overview of transformer networks, and we have seen transformers, how it is incorporated in vision. We have seen how vision transformer works. It's just an overview, and we have seen the attention mechanisms. We have seen how we have seen the code of vision transformers. It's just a very basic code. And alright, so I hope you enjoyed it, and I hope to see you again in the next video. Alright, thank you so much, guys. Bye bye.